Alright, let's just have a quick look at this idea of Venn diagram regions. Now, we've seen Venn diagrams before, but in this kind of chapter, we want to look at a focus on the different regions that we can actually sketch. And here are some pretty familiar ones. We've got these two symbols here, intersection and union. First of all, to remember which one is which, I remember it by saying, if I see this one that looks like an N, well, that means intersection. N has an intersection in it. Sorry, intersection has an N in it. And, well, the U, that looks like the U from union. So that's how I remember which is which. The confusing part can be, how do you remember which one means what? Well, if I think about an intersection, I need an overlap, okay? So the way that we reference it is that we say it's in both A and B. So I always think about the overlap. In this case, well, the overlap of A and B, which one's in both of them? It's just this section here. Just like that. So what about the union now? Well, the union is all of A or B. Okay, so think about like in a marriage, you put two things together. So I want all of A or B. That just means I shade in the whole of A and I shade in the whole of B. That's it. Now looking at this language, it can be kind of confusing if you just compare the and this or. So I always try and think of, use both A and B, that's the intersection, all of A or B, that's the union. Now the trap is when you see these symbols to think of these regions. That's not necessarily the case. This is just an example, and it's probably the easy example to use. Really, we want to think about intersection as an overlap between two sets, which can be anything. And the union, we want to think of all of that, so combining those two sets together. Let me give you an example. First of all, let's look at some of these ones here. Might use a different color for this. So here I've got like a few different kind of regions that we can shade in. So let's look at this first one, A complement. Remember, the complement is just everything that's not this one here. So I want everything that's not A. So essentially I'm just going to take A and I'm just going to block that all out. I'm going to shade everything that's not A. So I've got all this part here. And actually, I've got everything outside the box as well because that's not part of A either. So I can shade all of that in. Just like that. Okay, let's look at something like this now. In this case, I'm asking for A complement intersection B. So I already have what A complement is. If I just draw over to the side here what B is going to be, I mean, it's pretty clear that B is just this whole shaded region here, including this part here. What this is asking for, A complement intersection B, it's saying, okay, if I have these two here, what's the overlap? What's in common with both of them? Well, if I compare them, I can see really clear the part that is the same is just this part that's only in B, so not that overlap section. So intersection means overlap. I just want to highlight this part here. Okay, so this can be thought of as only B. What about this one here, B complement? Now remember, complement, we can use a few different notations. We can say that's C there, or we can use a dash. Or B complement, that's everything that's not B. So I just shade in everything that's not B, and that outside part is shaded as well. All right, now we're going to get a bit tricky. What's the union between A complement and B complement? Remember, union means all of. Either these or these, okay? So get out of the habit of thinking, oh, union, I just shade in this region, okay? We have to actually look at the two sets here, A complement and B complement. Now, conveniently, we've got both of them right above. We've got this one and this one. And so union means I just shade all of those things put together. You'll notice there's actually one part of these Venn diagrams which isn't shaded at all. It's actually this intersection part here, okay? So A complement, union B complement, well, I just put these two graphs together and I shade in everything except that intersection part. Just a lot of coloring in. There we go. So the only part that's not shaded in is that middle part there. A complement intersection B complement. Okay, so that's saying when I have these two here, what's the overlap? And if you compare these two graphs, sorry, these two Venn diagrams, then what's in common? Well, it's just these outside parts. Okay, that's what intersection means. What's in common? What's the overlap, right? So just the outside bit. Now, they can sometimes even introduce brackets. Now, brackets can seem like they're confusing, but just think about algebra, right? The brackets mean whatever's on the inside, I apply this, whatever's raised to, whatever's outside to the brackets. Okay, so whatever's on the inside, I apply this to all of it. Okay, so this is saying A intersection B, which I already know looks like that, okay, because this is actually A intersection B now. I know that's going to be that part, but the complement says I want everything that's not that shaded section. So I want everything that's not this shaded section, so it's actually going to be this. Everything that's not that overlap between A and B, that's just all of this. Okay. Everything except that overlap shaded section. Almost there. We've got two more to go. A intersection, B complement. Okay. So remember, intersection, I'm thinking overlap. What's in common? I already know what B complement is. That's over here. What does A look like? Well, A is just, if I drew my Venn diagram, A and B, A would just be everything inside A. I'm going to do it in red so you can see it. Okay, so I'm thinking, what's the overlap between this and this? Well, the overlap really is only that part there. That's only in A. That's only A. Okay. In the same way that this was only B, this one's only A. Last one here, A complement union B complement. Well, remember, union means I put all of it together. I've got A complement here, I've got B complement here, and I've actually done this one already, so don't need to do that one. So yeah, that's how we can shade Venn diagrams and their regions.